All right, so this is Math 145, Section 1.3. And here we're talking about basically the fundamental way that we sample in statistics. So we're going to talk about this, very important, that it's random, that people or cars or crayons or whatever you're studying are chosen at random to be a part of that sample. Now again, remember, this whole idea of sampling comes from this desire to know about a large group called the population, right? And we sample a smaller subset of that group to figure out what is true about the larger population. If I wanted to know about all Americans and their preferences for video games, I probably won't get very good information if I just simply ask my 10 good friends. I would need to truly try to get a representative sample. I want to get as many parts of the population, as many ideas out there in my sample. So, the definition of random sampling is simply just a process of using chance to select individuals to be in the sample that creates a random sample. Now, it is true, because samples are selected randomly, we are going to assume that it is a microcosm or smaller but similar portion of the population. Let's look at the definition of random sample here. It's simply one where the individuals from the population, so everyone, all have the same chance of being selected for the sample. And that's important. We need everybody to have the same chance of actually being in that sample. We do pick them randomly, and that will be true. Now we've got further a simple random sample, which is denoted by SRS oftentimes. We're going to introduce a little bit of notation here. So we're going to look at this definition. It simply says a sample of size n, notice lowercase n, is the size of the sample, or the number of elements or individuals that are in the sample. This is from a population of size capital N. So capital N will be the population size, and lowercase n is the sample size. Those are letters, capitalization included, that we'll see quite a lot through the semester. So keep that in mind. And then it says it's obtained through simple random sampling if every possible sample of size n has an equally likely chance of occurring. That happens to be true, but really more importantly, I think you need to remember every individual in that population has the same chance of being selected. That's really, you want to focus on that. And it's called a simple random sample. There are other methods we'll talk about in 1.4 in a little bit. Read over that definition of frame. Pause me down, meet me back here. Okay, so like it says, a frame is simply the list of the individuals in a population. We're going to see this on the very next page. Real quickly, we're going to label them with numbers 1, 2, 3, blah, 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 through capital N. Notice how capital N, because that's the number of individuals in the population, right, described up here. All right, we are on the next page going to obtain a simple random sample. So why don't you go ahead and read number 1 there and just kind of get an idea of what we're going to do. It does tell you how to get random numbers on your calculator, and I'll go ahead and include a short video of that, but that's really minor. You're not going to see it in homework. They're always going to provide you some random numbers to do the problems with, or else everybody's answers would be different, and that would be hard for my math lab to deal with. So these are the random numbers that we'll be using, but go ahead and read that setup for number 1, and then of course pause me down, meet me back here. All right, so I've got these 30 people in a large club, and it says the leaders of the club wish to survey its members. We are going to try to get a simple random sample of size 10. Okay, so first of all, just using our notation from earlier, capital N is the number in your population, that's 30, and lowercase n will be the number that we want to actually ask our question, right? So I have listed out my frame. And again, this thing here, this listing of every population member is our frame. And you'll notice I listed people using 2 digits, so 01, 02, 03, so on, until of course you got to Josh there at the end, who is number 30. Okay, now I will, at the end of this, I'll talk about this calculator stuff, but for now I'm going to put that on hold, and I'm just going to say this is my calculator random number generation that I got earlier. The idea here is that you can use these random numbers to select 10 of these 30 people, and basically we're just going to go through, like this thought bubble here says, we're going to go through and mark off these random numbers in increments of 2, and if a 2-digit number that we mark off relates to one of these 30 people, then they are in my sample, and if not, I'll just ignore it. So here I am going to start off. I'm going to go 94. I ignore the decimal points, they really don't matter at all. And then the next 2-digit numbers, 35, and then 97, 40, and 25. Now, again, 94 is not a person in my 0, 1 to 30. So I'm just going to ignore it. 35, next one, I'm going to ignore it. 97, not in my population. I'm ignoring it. 40, ignore. 25 is actually the first one that actually is a person in my sample. So my sample is going to first off start off with number 25, which notice up here is Kristen. So Kristen's going to be the first person in my sample. And I'm just going to keep going back to the next line. So 90, then I'm going to ignore it. 83, ignoring that. Next one is 18. So that person, number 18, is Shalon. She's up there. We're going to put her in my sample. Next one, 86. I'm going to ignore that. Now you'll notice I have a single digit there at the end of the second line, this 1 here. And since I'm looking for 2-digit increments, I'm just going to flat out ignore that. Okay? Go to my third line, and I'm going to do 14, 66, 87, 82, 92. And in fact, the only one that relates to a person in my frame is 14, which I look it up there. Oh, that's savvy. Right? So probably should pause me down, see if you can complete that sample. Again, remember, you're going until you get 10 people. And also, you might think about, what are you going to do if you get the same number twice? Go ahead, pause me down, see how you do. Okay, so I went back through and I recircled the ones that were selected for the sample in red, so you could see that. Those were the numbers, 25 at the beginning here, and then 18, and then 14. And so I just kept going. And next line, again, so many of these numbers just did not apply at all to our frame, so we just ignored them. I got 01 and 05 from the fourth line of random digits, and they are over here. Trey and Bob, it looks like, and I keep going. And again, so many can be ignored. I got 09 and 18 on the fifth line. And so you'll notice 09 gets in there because he's a new person, but I'm not going to write 18 down because Shalon, number 18, is already there. So I'm ignoring that second 18 because I don't want to give Shalon more input than she deserves as only, being one person. So I keep going, and I'm now on, I think that's the sixth line, and 73 gets ignored, 38 gets ignored. I got 12, so I put him in. So there's that. And again, 31 gets ignored, and there's another 12 that just gets ignored as well because it's already there. Okay, and I keep going, and I ended up with 04 from that line, 22 from the second to last line, noticing how 09 was a repeat, so of course Steve doesn't get written down again, and last line gets me 30. So they all get put in here, and I ended up with a list of 10 randomly selected people. And that's the idea, okay? This is, by the way, what you call sampling without replacement, for the very reason that we were talking about, that you would not ask Shalon or Steve the question twice simply because their number came up twice. Once you survey a person, it does not make sense to survey them again. So that's that. We'll go to the next slide, and I'll show you a little bit of the calculator stuff if in fact you're interested. Like I say, it's not going to come up in our homework, but if you do statistics elsewhere, you might very well find generating random numbers is something you need to do. All right, here we go. Here is my TI-84, and this is how we find random numbers. I'm going to hit the math button, which is 3 buttons down there from the very top of the calculator, and hit that. Now, then I'm going to go to, across the top menu, to PRB, which stands for probability. And you'll notice number 1 there is RAND, which stands for random number. And I'm going to hit enter. And if I just simply hit enter again and again, it will generate random numbers. And that's the easiest way to do it. Just hitting enter again and again and again. And what you might be doing in practice is simply saying, I'm just going to kind of throw out a bunch of, and then I'll start there at the top with my random numbers, okay? There is also a way to put a seed into the random number generator, which will create just slightly different random numbers. It sounds a little weird. Technically, random numbers aren't random, and so this seed helps a little bit. So if you hit math, and then the PRB, and then hit rand, and then before you hit enter to start, you just put a number in there from 1 to 9, and it will generate random numbers. You just ignore the decimal points, or perhaps you might come to a rule beforehand and says, I'm going to just use the digits to the right of the decimal points. And that's perfectly fine because, again, it's random. So just keep random, da-da-da-da, and you'll see that just keeps going for as long as you possibly need it. Okay? And that's getting random numbers out on your TI.